In this video, we're going to continue our talk about servicing air conditioning equipment by talking about pressure testing and leak repair. Now, locating and repairing refrigerant leaks can be one of the most frustrating things a refrigeration and air conditioning technician has to do. When you find low head pressure, low suction pressure, a lack of cooling, these are all good indicators that a system has a leak. The methods for locating leaks will sometimes vary with the refrigerant used. However, all methods have one procedure in common, and that is to apply pressure to the system. If a technician determines that a system has a leak, a gauge set should be attached to the system. Again, remember, we don't want to necessarily attach gauges to a system if we don't have to. If no pressure is present in the system, then the refrigerant has leaked out entirely. Therefore, the technician will need to apply pressure to the system to begin locating the source of the leak. If the system contains refrigerant already, leak testing can continue without applying additional pressure. If the system is empty of refrigerant and inert gas, such as nitrogen and carbon dioxide, is used to pressurize the system to check for leaks. Now, why an inert gas? An inert gas will not change pressure based on temperature. Once you put 170 psi into that system, as long as there's no leak, it's going to remain 170 psi regardless of what the temperature does. Okay, inert gases do not have a temperature pressure relationship, or a very minor one. It is always preferable to use an inert gas for leak detection before charging an empty system with more refrigerant to detect a leak. If the entire refrigerant charge has not leaked out, however, use the refrigerant already in the system to check for leaks. Never use oxygen, acetylene, or any other fuel gases to develop pressure in a refrigeration tubing, piping, or equipment. Oxygen will cause an explosion in the presence of oil. Acetylene will become unstable and explode at pressures over 15 psi. The following inert gases can be used: carbon dioxide, nitrogen, or argon. Quite honestly, the majority of the time you're going to use nitrogen. These three inert gases are safe if used with pressure regulators and a pressure relief valve. Most of the time there's a pressure relief valve that's part of your regulator. At the start of testing, a positive pressure of 5 to 30 psi is necessary throughout the refrigeration system. Large leaks can be detected by audible hissing sounds and can be easily found using soap bubble solutions or an ultrasonic detector. Smaller leaks may not be audible and might require the use of electronic leak detectors or other tools. Okay, let's start here. Anytime you have a refrigeration leak, the first thing you should do is look at all fittings and look for oil. Okay, oil or dirt buildup is a sure sign of a leak because the refrigerant oil will come out with the refrigerant. The next thing you want to do is check all fittings, including your Schrader connectors, because Schrader cores are sometimes very good sources of leaks. Check all fittings with soap bubbles. Okay, you can use window washer fluid. You can use dish cleaning soap like Dove or one of the other ones. But again, you want to use, they also make a stuff called Big Blue, comes in a squirt bottle. But you want to use a soap bubble solution, okay, as your primary source of leak detection. If the soap bubbles, and if you can't find any signs of oil or audible leaks, then you can move on to other leak detection tools, okay? Try the easiest stuff first. Electronic leak detectors, halide torches, and refrigerant dye detect refrigerant vapor and will not detect nitrogen or other inert gases. So there's two main methods for pressurizing a system to test it if the system's entire refrigerant charge has already leaked out. One method involves charging the system with inert gas. The second method involves evacuating the system and charging it with a small amount with nitrogen and a small amount of its specified refrigerant, about a 10% mixture. Testing with an inert gas such as nitrogen or carbon dioxide needs to be done with caution. The nitrogen cylinder is connected to the gauge manifold, and the manifold service hoses are connected to the low and high side service valves on the system. Nitrogen is allowed to pressurize the system through both the high and low sides. It's safest to pressurize the system to the lowest operating head pressure. Okay, for example, on R134A systems, a pressure on both sides less than 170 psi should be sufficient. Larger systems using refrigerants such as R410A may operate at higher pressures. Now, the other thing you really want to do is go to the evaporator and find the service tag or the data plate on the evaporator. Find out what the test pressure is. Okay, it's listed on the service tag or the data plate. That is your maximum test pressure you can use, so don't go over that. Before using nitrogen or carbon dioxide to test a system, look at the system nameplate. And again, on the low side of the system, it will give a recommended test pressure. If these pressures are not known, do not exceed 170 psi when testing with carbon dioxide or nitrogen. You can actually blow the joints in the evaporator apart. If the system pressure drops after being charged with an inert gas, the system has a leak. The technician should look for leaks at tubing connections using a bubble solution. Need to look for leaks near bent or crimped tubing, poorly constructed joints, in other words, if you see bad brazes or bad solder joints, and tubing that rubs against a moving part, such as an evaporator or condenser fan motor. You also want to look for tubing that is close to the compressor and tubing that might be rubbing against the outside of the condenser. For leaks at flare connections, the tubing flare can be incorrect, and the flare nut may be loose and need to be tightened, or the flare nut may be stripped. The best way to fix a leaking flare connection is to cut the old one off and form a new one. If a leak cannot be found using a bubble solution to test the area that's typically leak, then the system should be charged with a refrigerant and nitrogen mixture. Again, 10% refrigerant, 90% nitrogen, so that the leak detecting devices such as electronic leak detectors can be used. Even though it is illegal to knowingly vent refrigerant into the atmosphere, the EPA does allow refrigerant to be released when it is being used as a leak test gas. Again, not a full charge of refrigerant. Mix a little bit with the nitrogen. To repair a leak, recover the refrigerant from the system. After recovery, to make sure the system pressure is at 0. Now, if you have a nitrogen and refrigerant mixture, you're not going to recover that. You're going to just release that. If you just have nitrogen in the system, you're not going to release it, or you're not going to recover it. You're just going to release it. Purge the system with inert gas, usually nitrogen, prior to brazing, and flush any debris from the tubing. During brazing, arrange for a continuous low pressure flow of nitrogen, usually 1 to 2 psi, to pass through the part of the system being brazed. This prevents oxidization from forming inside the tubing during brazing. Never braze a system with refrigerant or high pressure in it. The heat can cause the refrigerant to break down, and it can create toxic fumes. There are some newer systems out that use butane, propane, and other combustible gases as high efficiency, low ozone depletion, low global warming refrigerants. If you see a tag that has one of the newer refrigerants, make sure you're aware of what it is before you braze it. It can explode. So again, you have your system. If you are brazing any place on a system, make sure you allow a low pressure charge of nitrogen to flow through the system from the low side to the high side, or from the high side to the low side. Usually go whatever direction. If it's a heat pump, be careful about where the reversing valve is. And again, just remove the Schrader cores on each side. Before performing the repair with braze, it's important to know what material the leaking part is made of. Refrigeration systems are made of copper, steel, or aluminum. And this goes for air conditioning systems as well, by just using refrigeration systems. Could be commercial refrigeration, could be commercial air conditioning, could be light commercial residential air conditioning. It's still a refrigeration system. A leak can form on any part of the refrigeration system. Steel and copper can be brazed. Aluminum can be soldered or brazed, but be very careful with aluminum because if you get it too hot, it's going to melt and make the problem worse. Aluminum can also be resistance welded to steel or copper or repaired with an epoxy. Most aluminum found in current air conditioning systems is in the evaporator coil. It is not a good idea to perform long-term fixes on evaporator coils, okay? The fixes you do on an aluminum evaporator coil, if it's aluminum tubing, will not last long at all. It's because of the temperature changes that are constantly occurring, the movement from heating to cooling. The coils don't last very well once they're repaired. The best thing to do with an evaporator coil, if you have an aluminum tubing, I'm not talking aluminum fins, because aluminum fins can be on copper tubing, but if you have an aluminum tubing evaporator coil, the best possible routing and course of action is to perform a short-term repair to get the customer cooling, but make it very clear to the customer and right away quote out a replacement evaporator coil, look at warranties, and do what you can for the customer. Okay, because the bottom line is that coil needs to be replaced. To determine what system is used, scrape the surface. Steel is a gray, white, hard, and magnetic. Use a small magnet to test it. Copper is reddish in color when scraped and is not magnetic. Aluminum is white, soft, and non-magnetic. Leakage at brazed or silver solder connection can be repaired by cleaning the joint, coating it with flux, reheating the area so that the original brazing or solder melts, and reapplying the braze or silver solder. Steel tubing usually has a lengthwise seam. This seam must be cleaned prior to brazing. Clean the seam with a wire brush lengthwise or fill of enough metal to remove the seam. Clean flux and make the repair. Repairing leaks with epoxy resin. Epoxy resin is a thermosetting polymer that forms a string adhesive. It can be used to repair cracks and leaks in evaporators and joints. Epoxy resin has good adhesion qualities to aluminum, steel, copper, and many plastics. However, again, there hasn't been much luck repairing evaporator coils with epoxy resin. The most effective type of epoxy resin is the two-part system, which consists of an epoxy resin and a hardener in jars or tubes. The two substances harden at room temperature when mixed together. One part epoxy resin must be heated in order to harden. The shelf life of most resins is about 6 months. The epoxies should be purchased from a refrigeration supply house because some epoxies available elsewhere may not be compatible with refrigerants. Always follow manufacturer directions and instructions. Contact with skin should be avoided. Now, just as a hint, when you're sealing an evaporator with an epoxy resin, it doesn't hurt to put the system into a slight vacuum, not a deep vacuum, a slight vacuum. That will pull the epoxy resin into the leak. Okay? You can use bubble solutions to find the leaks, okay? Here's a small leak, and here's a large leak when you spray it with soap bubbles. By far, this is the best way to find refrigerant leaks. Big Blue and Brush on Blue are two leak detectors that are usable. Comes in a gallon jug, and you can refill whatever spray bottles or whatever you use. Wipe down the tubing and fittings before using bubble solution because over time, or after using bubble solution, over time the solution can harm the copper. Compare it to other methods. A bubble solution is an easy, low-cost method of leak detection. A disadvantage to the bubble solution test is that large leaks that are high pressure can blow through the solution so no bubbles will appear, but you should be able to feel and hear those. Refrigerant dye leak detection involves charging dye into a refrigeration system and observing the area suspected of leaks during operation. While the system is running, a technician visually inspects the various parts for dye color, which will be produced at the point of the leak. Refrigerant dye is injected into the system and the system is returned to normal operation. The dye method depends on the oil circulation rate. Most leaks show up in a short time. Some can take up to 24 hours, especially small leaks. So if you're using a dye, you put the dye in, return the system to normal operation, and you might have to come back to find the dye leak locations. Now, before you use dye, be very careful of this because there are some manufacturers of compressors and equipment that will void the warranty on the compressors if you use the wrong dyes or even some dyes to start with. When using this method of leak detection, avoid injecting excessive amounts of refrigerant dye into a system, as this can reduce the cooling capacity of the system, lower the lubrication viscosity, and even damage components. So this is an example of a dye kit. Again, the injection gun uses a small dye cylinder and connects to a service port. Fluorescent dye leaks detection uses fluorescent dye and an ultrasonic light to detect leaks. While circulating a fluorescent dye through the system, a technician visually scans refrigerant tubing with an ultraviolet light. This method can be used with a variety of refrigerants, including R134A. Fluorescent, so again, if you're looking at this with a UV light, you will see the dye leaking out of a condenser coil. Halide torch leak detection involves burning a fuel gas near a copper plate and using a rubber hose to siphon air from the area suspected of leaking refrigerant. If the flame changes to green, a refrigerant leak near the inlet of there's a refrigerant leak near the inlet of the rubber hose. The rubber tube draws air from its open end to the burner, where burning refrigerant turns the vapor flame to color to green. This is an example of a halide torch kit. We don't use these very often anymore because of the possibility of explosion around some of the refrigerants, and the fact that electronic leak detectors have become much more popular. Electronic leak detectors, by far, other than soap bubbles, are the best way to find leaks. Okay, the detectors use electronic sensors to determine if a refrigerant leak is present. They are often powered by batteries and are typically able to detect very small leaks. However, there is a learning curve to using them, just like about anything else. Electronic leak detectors are turned on and adjust to atmospheric pressure. A leak detecting probe is passed slowly over the surfaces suspecting of leaking. Air is drawn up into the sensing probe by a small pump inside the unit. If there is a tiny leak, refrigerant is drawn into the probe. The detector will emit a piercing sound, flashing light, or both. In some models, the frequency of the sound or flashing load increases in relationship to increasing concentration of refrigerant. The closer you are to the leak, the louder and faster the sound. Try to minimize the draft when using electronic leak detectors because the refrigerant can get blown around. Shut off any fans and other devices that will cause air movement. Always point the sniffer below the suspected leak. Refrigerant is heavier than air. Move the tip slowly at the rate of 1 inch per second. Do not let the probe come in contact with the surface. It can become contaminated by water or other substances interfering with proper operation. These tools are very sensitive tools, okay? They can become contaminated. They a lot of times have filter material in them, and sometimes the sensors are changeable out. So read the manual that comes with it and find out how you're supposed to service it. It's important. Electronic leak detectors are able to detect CFCs, HCFCs, HFCs, and blended refrigerants. So it's not necessarily to determine the refrigerant in use or reset the meter for different refrigerants. Some additional help that I can give you to locate refrigerant leaks: check connections early in your search. Leaks often form at tubing connections such as brazed areas and at high stress or high vibration areas such as tubing near a compressor. Look for oily or dusty areas because a small amount of oil often escapes through the refrigerant leak. Oily leaks are often good indicators that a leak is nearby. Dust often gathers and sticks to oily areas. Eliminate any wind or breezes by blocking off detection areas with a cardboard or other metal. Block out any bright lights such as sunlight when using color changing methods like halide leak detectors or fluorescent dyes. If possible, when using an ultrasonic leak detector, turn off any equipment that could produce sounds that would cause the detector to sound a false alarm. It's useful to operate the system if possible prior to leak detection and to build up pressure when using soap bubbles or refrigerant dyes. The higher the pressure, it will force refrigerant out into a larger spray pattern. So leak detection is important. Okay, there's some EPA regulations that I'm not going to get into in this video about when leaks are required to be fixed. But the bottom line is, okay, it is sometimes a lot less expensive to fix the leak in the long run than to have to decrease in operating efficiency. The fact that you have to replace full charges of refrigerants as a blend, and the fact that you constantly have to keep going out there for a customer service call. So fix the leak the first time, deal with it, and then you don't have to go back for the same problem over and over and over again.